the celestial superhighway.
Welcome to Stargazers. I'm Dean Regas, astronomer from the Cincinnati Observatory.
And I'm Marlene Hidalgo, science teacher from Miami, Florida.
And I'm James Elberry, director of the Kika Silva Pla Planetarium in Gainesville, Florida.
Next week, the moon will have a close encounter with three bright objects in our night sky: the red planet Mars, the blue giant star Spica, and the ringed planet Saturn.
Have you ever wondered why the moon always seems to follow a path that brings it close to the planets? Why does the moon never go through the stars of the Big Dipper, for example?
Yes, and why do you never see planets among the stars of Cassiopeia or Perseus? They all seem to follow the same pathway through the sky, as if they're traveling on a celestial superhighway.
Well, we have the answer for you. Let's show you. By studying the movements of the planets, moon and sun against the background stars, modern astronomers were able to figure out how our solar system formed. This hypothesis was later supported by observations made using the Hubble Space Telescope.
Deep inside the Great Orion Nebula, astronomers found what are believed to be other solar systems forming around brand new stars. As gravity makes these clouds of gas and dust collapse on themselves, they begin to spin. As they get smaller, they spin faster, and eventually they flatten into a disk.
Over time, material begins to clump together throughout the spinning disk of gas and dust. This process is called accretion. When enough material accretes in one place, you get asteroids, comets, moons, and planets.
As far as our solar system goes, the momentum from the original solar nebula is what we see today as the motion of the planets through the sky. Here's how we figured it out. Let's look at the sun's apparent motion first. During the course of a year, the sun appears to gradually drift eastward against the background stars. This yearly apparent motion of the sun is caused by our Earth's motion around the sun.
Now, let's imagine viewing this from space, high above the solar system. If you draw a straight line of sight from the Earth to the sun, from the Earth's perspective, the sun will appear to be in front of the stars in the background. As we orbit the sun in a counterclockwise direction, from Earth it appears that the sun is moving from right to left against the background stars.
This path that the sun makes against the background stars is called the ecliptic. We call it the ecliptic because the moon follows very close to this path, and when the sun, moon, and Earth align, we experience eclipses. The planets and many asteroids also follow a path through the sky very close to the ecliptic.
If we extend this region of space outward in a plane away from the sun, we get what astronomers call the ecliptic plane. This represents the region of space once occupied by the accretion disk from which the planets formed. The original momentum of this disk is what we see today as the movement of the planets in their orbits. And that's why you never see planets or the moon far away from the ecliptic. Furthermore, the background stars that follow the ecliptic form the constellations of the zodiac. Therefore, the planets, the moon, and sun always stay within the zodiac.
So next week, you'll get to see a great example of this. We have our sky set up for Tuesday, March 18th at 10 p.m. facing east. You'll see a waning gibbous moon forming a triangle with the red planet Mars up and to the left, and Virgo's blue-white star Spica up and to the right.
If you go outside after midnight that same night, you'll see the ringed planet Saturn rising in the east in the constellation of Libra the Scales. If you draw a straight line from Saturn over to the triangle formed by the moon, Mars, and Spica, you'll see the path of the ecliptic.
Let's fast forward one more night, and then, just after midnight, the morning of March 21st. Now, the moon is right next to Saturn. Did you notice how the moon moved along that imaginary line between Mars and Saturn? Making consistent observations like that, recording those observations, and then predicting future outcomes is essentially what scientists do.
Observe, record, predict,
and ultimately make sense of an ever-changing sky.
And it's all possible when you keep looking up.